Hello students, today we are going to learn how to trace a cubic polynomial. So to start with, since sum of coefficient of this polynomial is 0, we can easily check it. Coefficient of x cube is -1, coefficient of x square is 1, coefficient of x is again 1, constant term is -1. If we add all these coefficients, then we get 0. So we can say x equal to 1 is a 0 of given polynomial. Now let us use synthetic division to find other two zeros of the polynomial. So write coefficient of given polynomial first. Now since x equal to 1 is a 0 of given polynomial, so write -1 as it is. Multiply these two terms, we get -1. Add these numbers, we get 0. Now multiply 1 into 0, we get 0. Add these number, we get 1. Now 1 into 1 is again 1. Add these number, we get 0. Therefore, given polynomial can be written as x minus 1 into coefficient of x square is -1. So this is negative x square plus constant term is 1. If we factorize this minus x square plus 1, then we get 1 minus x into 1 plus x. If we multiply this term by -1, so it becomes x minus 1. So x minus 1 into x minus 1 can be written as x minus 1 whole square into 1 plus x can be written as x plus 1. So our polynomial can be written as x minus 1 whole square into x plus 1. Now all zeros of given polynomials are x equal to -1. So what are the zeros of given polynomial? X equal to -1 and x equals to 1. We can write 1 comma 1 or 1 with multiplicity 2. With so basically we are able to find all zeros of given polynomial. Now we find something called y-intercept. So for y-intercept or y-intercept, we simply put x equal to 0 in the given polynomial. So we get p0 equals to all these terms becomes 0 and we get -1. So 0 comma -1 is the point from where this curve should pass. So finally we have y-intercept. We have all zeros of this cubic polynomial. Now let us see how we can draw sign chart. So for sign chart, let us write all zeros of this polynomial. This polynomial is simply p sub x is nothing but negative x minus 1 whole square into x plus 1 or 1 plus x. Now, in order to put sign chart, since we know zeros are -1 and 1, so trace a number line and mark -1 and 1. So now, since x minus 1 whole square is always positive, so this term is always positive, only this negative sign and sign of this term decide whether our polynomial is positive or negative in interval. So suppose x is more than 1, so this term is positive. As a result, product of all three numbers becomes negative. Now, if x lies between -1 to 1 to 0, so this term is again positive. This is always positive. This is negative. So again, our polynomial is negative if x lies between -1 to 1. If x is less than -1, so this term is negative this time. This term is always positive, and this term is negative. We can write this as -1 also. So product of all three terms is positive. So sign chart is very simple for this polynomial. If x is more than 1, then our polynomial is, if x is more than -1, then our polynomial is negative. And if x is less than -1, then our sign of our polynomial is simply positive. And it can be seen very easily from the polynomial itself, because leading coefficient is negative. So when x approaches to infinity, uh, basically x cube is the term which produce maximum value. Now let us see how end behavior change. Since we know if x approaches to infinity, y keep decreasing. And since this is a polynomial, so there is no horizontal asymptote. Polynomial is simple, smooth curve, everywhere continuous and differentiable, we all know. So if x approaches to infinity, our function y, or we can say p sub x approaches to negative infinity. And if x approaches to negative infinity, we can see if x approaches to negative infinity, our function, our polynomial is positive and it keep increasing. So p sub x approaches to infinity. Okay, so now we have so many information about this polynomial. For example, zeros of our polynomial is 1, -1. We know y-intercept of this polynomial is -1. Plus we know in behavior of the polynomial. So it's time to trace the curve. And how we trace the curve? What would be the core idea to tracing the curve? So we know from negative onwards, this function is always negative. From -1 onwards, so -1 is say this point, and if x equal to 0, y is -1, so this is somewhere here. At x equal to 1, it does the curve. So polynomial should be something like this, and keep going like this. However, let us see the actual curve, how it look like. So here is the polynomial. Here is the polynomial. We know this curve is passing through -1 and 1. And since multiplicity of x equal to 1 is 2, so it turns from here. Also, y-intercept is -1. And since we are not using calculus, we are not sure whether this point is point of local minima or not. So curve look like this. And we can see very easily that if x approaches to infinity, y approaches to negative infinity. If x approaches to negative infinity, our curve approaches to infinity. Let us see one more curve and trace this curve also. So here we can know that sum of coefficient is not 0 this time. So x equal to 1 is not a 0 of this polynomial. So let us add uh, coefficient of alternate term. So 1 plus 0 is simply 1, and -3 plus 4 is obviously 1. So, so 1 plus 0 is same as -3 plus 4, means sum of the coefficient of alternate term are same. So we can say that x equal to -1. So we can say that x equals to -1 are is a 0 of this polynomial. In order to find other zeros of the polynomial, let us use synthetic division. So for synthetic division, let us write all coefficients. So 1, -3, 0, 4 are coefficients. Now put x equals to -1, because we know -1 is a 0 of this polynomial. So write 1 as it is. 1 into -1 is -1. add this. So we get negative 4. Negative 4 into negative 1 is basically plus 4. Add them, we get 4. 4 into negative 4 is 4 into negative 1 is negative 4. This sum is 0 as expected. So we can rewrite this polynomial as x plus 1. Why x plus 1? Because x equals to negative 1 is a 0 of this simple polynomial. So x plus 1 is a factor of this polynomial, and this can be rewritten as x square minus 4x plus 4. After factorizing, this term becomes x minus 2 whole square.